So as you can see, my little mini mill is now in its box. The cabinet has been more or less completed, nearly, not quite. On the last video we were working on the inside and glass fibering everything. That's all done. The cabinet is now pretty much complete. More work needed on the doors and the windows and stuff, and I can't decide whether I'm going to put a door over the front of this or not, but that's the coolant chip tray. It's got a desk big enough to get a piece of A4 on, and the control cabinet is mostly wired in, so it's coming along. So if you're interested to see how I got on with this and how I got it this far, join me after the titles. I've temporarily just put this one clamshell on so that I can mark positions of where I need to add some metal in the back here, and it's going to need a fair bit of fettling to get it to fit properly. That should be at the same point there, so that's clearly got to move that way and down somewhat. Sorry, got to move that way and down a little bit. So there's going to be a fair bit of fettling to get this all to fit once I get that far. Anyway, let me mark the positions of these chutes, and round the back here I need to just think, I need to project this corner down to here, and that will tell me where, because I'm going to have to weld on something on the back here to stop the little bit of coolant that will make it this far from coming out the back of the machine. So I need to sort that out as well. Now I need positions for mounting screws. So there's a screw there I've got to clear. So if I go 50 in, that should do. So if I go 20 in from the outside edge, I've cleared it. Let's do this one, 20 in from the outside edge. There we go. Do you know what? This thing, well, how ironic. You get ready to throw it in the bin and go on to the trouble of finding the other old-fashioned way of doing it, and the bloody thing decides to work. The irony. Right. These mounting holes are actually threaded. I think they're threaded by the looks of them M12, because this is a 10mm drill and it fits in there quite easily. But I don't think I'm going to use those. I think I'm going to just put a bolt straight through and thread the support I made. So I just need to mark the position before I move the mill. How's that done? Yeah, so. And lastly, before I take the mill off, I need to mark the position of this support. I could do this with the mill off, but this way I know exactly how far the mill has compressed the wood. This. Right. Right, that should be enough. Right, so here's my plan. I've got a proper certified lifting eye on that now, as you've just seen. So I'm going to just lift it up just so it clears the plinth. Slide the plinth out of the way. Slide this dolly underneath, and then let it down. Hopefully, spending a minimum amount of time suspended in free air. So let's see if we can do that. Hopefully there's enough travel on this crane. It's floating. Nice and gently. Oh. Moving these machines by yourself is not something you do lightly, believe me. Oh, blimey, that's heavy. That is heavy. This really does need some work. Made in America. I think it might be. It's a number 6. I don't know. Can't read it. I polished this up a little bit, this tap wrench, with a wire wheel, and it turns out it's made by a company called GTD from Greenfield, Massachusetts. Massachusetts. And it's obviously made in the USA, and it's a number 6. The company, it seems, still exists, but I've looked on their website and I can't find this particular style still available. But my dad worked for a while for the American Air Force here in the UK, and as an aircraft technician, I believe, and as a result, I think this is left over from his toolkit. That's certainly where it came from. Yeah. It's not bad quality, to be perfectly honest. In fact, I'd go as far as to say it's really good quality. It's just, it needs a bit of TLC. A bit like myself. So I think what I'll do is the power drawbar system. I'll put a bracket out the back here, a piece of this timber, and stand it on that and secure it to the back here. That will work nicely. And that will give me more space in the base of the unit for the coolant tank. This is what I'm going to do. That's the PC. I could replace that with a much smaller PC, but to be perfectly honest, it works and it's reliable, so I'll leave it be. So after a bit of fiddling and faddling about, this is the one of the filter membranes. That's, I think, about the right height for it. So the tank will, these are just some boxes to demonstrate it. The tank will sit below here and a little bit below here. The filter will be lower as well, but this is roughly where I will need the aperture for the lower half of the drain to go into here. So now I know what I'm doing, I can start mocking up some bits. That means we end up with a slope, not a very big slope, has to be said. You probably can't see this very well, but I've marked this board the same width as this panel with a 14mm line from the edge. So that then gives me the point in space that we're going to put the angle. There we go. That's the top edge of that side. Now I can do exactly the same this side. Oops, there we go. Right, I now need to. This effectively will be the top edge of this sloped drain. So now I need to add the thickness of the board, which I will do. So now I need to transfer this drawing onto the next, onto the new panel. We now have two mirror image panels. Let's go and try them. One. So just to demonstrate what I've done here, that PC, horrendously big as it is, will slide in there like so, and it will clear the drain on the top. So all looking quite good. Yeah, that's better. The first two chutes are in. Let me, and I've just put this in as a test fit. Let's get rid of this. That's looking good. Now I need to, I'll bring you around to show you. So as you can see, they're both in, and I've marked the width. This is the size of the filter that's going underneath. And excuse me. The reason that the hole is a lot smaller than the actual aperture is that if I made the aperture the same size as this, which is 300mm or 12 inches square, then as the chips fall down, they'd build up on the edges and then they'd fall over the edges, whereas because it's piling up in the middle, it's going to pile up in the middle and then spread out like a little sugarloaf mountain, hopefully. So so this aperture has to be smaller, I think, than the available filter area. So now I need to develop the same hole width this way, and then develop the infill pieces to give me that that proper funnel arrangement. That's going to be tricky. Right. So that is going to be the size of the aperture, which is 12 centimeters or just under, what's that, 5 3/4 inches square. So now I need to work on on these pieces. So what I did, I know two dimensions. I know the length that way, and I know the length this way. That's sort of right and very wrong at the same time. I think with a bit of fettling that'll be close enough. So this is how far I've got with a bit of fettling. I reckon that's more than good enough. Just checking the frame still fits. That's looking pretty good, I have to say. So let me get these bits glued in. after a couple of hours of filling and sanding, the transitions are now smooth. There's radii in all of the corners, so that's ready to be glass fibered. And the tank, there we go, is also in the same condition. It's been fillets put in all the corners, and it's been well and truly sanded, ready to be glass fibered. So that's the next step. So while that first base coat of resin goes off, I've torn up the pieces to laminate to go in there, and over here, same thing applies here. This coolant tray is now ready to be laminated. There are the bits. So yeah, let's get on with it. It is the following day, and this is all nice and hard. It needs a sand, and I'll do that in a moment. But first, a little side project. I made myself what looks like a ship's funnel. Sadly, I ran out of printer filament twice, so I haven't quite finished it. And it was only a prototype anyway, so there's enough of it there to try that out. So let's have a look at this. Those of you that have watched the channel for a while will have seen me build this bench, and also the dust port in the middle that goes all the way through 4-inch waste pipe all the way to the dust extractor over there in the corner. And it's designed to take the dust off whatever machinery is in this on this bit of the bench. So I'll bring you in on a close-up and we'll have another look. This is a dust port that I made years ago, a standard Hoover Newmark Henry type Hoover pipe screws onto the top of that, and then that's designed to fit over a 4-inch waste pipe. That's fine and dandy, but that's not a particularly big diameter, and the dust extractor doesn't suck a huge amount of air through it, where a Hoover does. Don't know why. So I bought myself a metre of 3-inch 76mm flexible pipe, and I was always going to design an adapter that it fits, and luckily there's enough of this adapter to try this out, so I will try it in the near future. But the whole point is that it can swivel to wherever you happen to be, whichever machine you happen to be using. So so I think that looks like it's going to be a success. I'll take the top up and give it a go and see if it does suck a sufficient volume through. What I will need to do is make adapters for all of the machines though, because they're, you know, it won't fit a lot of these machines. Having sanded everything, let's just make sure that this all still fits. Oh yeah. Oh my, no teeth on that anymore. Whoa. Good God, it's almost like it was designed for it. Yeah. I think I'm going to have to add something to the front edge here to strengthen it up a bit. And there's the pickup tube. So there'll always be a little bit of fluid left in here, but it shouldn't be too bad. Bit of a discrepancy with these holes, they don't quite line up. Oh dear, I'll have to re-drill them. There we go. There you go, you'd almost never know. Oh, these are hot, 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 hot. Okay, a little bit of fettling required to get them to fit perfectly, but ow, 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 ow. That's that. And then to make it so we can have a lot of chips in there, I'm going to weld on an additional fence so it's a deep tray. That should do the business, shouldn't it? Go and cool my hands off in something cold. After a coat of paint and the nice mesh added to the bottom, I've finished the carcass for my chip tray. What I have done, as you can probably see here, there are holes in here. They're threaded and tapped M3 so that I can fit some aluminium bars to hold down the filler material. Lovely. Now I'll just mark the position and use these very old Gust Mass number 61 leather punch pliers to put the holes in. There we are. Now in theory this should be a piece of cake just to put all of these filters in. Right, next one. And finally this one. And if the gods allow, that will go straight in that hole from the other side. Perfect. So here we have it. Nice filter bed in the bottom here. The aluminium strips and hold the three filter elements in place. And on the bottom, it should hopefully just drip straight through. This weld mesh, as it's called, was I put that on just to support the filter material as it gets more and more chips loaded up on the inside. I didn't want to overstress it, so that's just there to support it. Not really sure it's necessary. The only other thing to do is to give it a go. I've absolutely no idea if this is going to work, so let me go and get a watering can. Before I put any water through here, because I don't know if it's going to work, I haven't got the faintest idea. The resistance to the water flowing through the filter depends on how fine the filter is, clearly, and it's a trade-off between how fast you need the water, the coolant to drain through, versus how many of the small chips you actually catch in here. So my guess is that I'll probably end up changing the mesh size in some of the filter blocks in here in order to get it so that it flows, because it's got to flow through here faster than the pump can pump it out of the tank, otherwise it will just overflow. So it's a trade-off, and I don't know exactly how it's going to work until we get it into the machine, because I'm also using just water here, and the coolant has got an oil in it, and the oil obviously is going to affect the viscosity, so it's going to be harder to push the water or the coolant through than it is water, because it's slightly thicker. Here we go, there's mud in your eye. But what do you know? That seems to work quite well. And just as importantly, my GoPro is still running. There we go. That still seems to be working. It wouldn't be the first camera I've drowned. In fact, it wouldn't even be the 10th camera I've drowned. Goodness me. Did a program for Channel 4 many years ago, and I think I ended up trashing nearly 30 grand's worth of cameras. But that's another story. So the tank has had its first coat of some very old yacht varnish. They'll get a couple more coats on the outside, then it'll be painted, and I guess it's time now to get the coolant pump mounted. So this is a stainless plate that came off the bottom of a door. I have seen these where they're adjustable, and I think that would be really quite useful, because this one doesn't really, with something as tough as stainless, doesn't really push hard enough. Anyway, now I mark those, I'll go and drill them and I'll join you back here. 20 minutes later, all the holes have been drilled, the pump mounting holes have been opened up and tapped. Although it's very thin material, the tap does seem to fit okay. So next up is just to break through the surface with a 3mm drill. This is the coolant pump. It's just basically a motor and a shaft that drives this little impeller. The coolant enters through the top here. This is upside down clearly at the moment. Gets spun out by this little impeller and through this housing, and then drives it up a hollow leg to the this spigot that then drives it up to the machine. So it really couldn't be simpler. The only tricky bit is to make sure that you get that outlet in line with that hole, because there's no orientation on this, so you can get it wrong. Now I want the outlet to be on the side. I could have it on the back. On the back. Yeah, I suppose it's probably easier, isn't it, on the back? Straight out the back of the machine. And no, we'll go with the side. That's easy enough to change if need be. Let's have a look on the inside. Oh. Here's the downside of this particular pump. You probably can't see that very well, but it looks like the coolant goes in through the top hole here, which means that it's got to be 45mm deep. So effectively 45mm times the volume of this is wasted coolant, because you'll never get it into the pump there. Having said that, my original, let me work this out. Right, having said all that, my original tank, and I'll drop a shot in here so you can see it, is 16 litres, and it was nowhere near big enough. This is 46 litres, so hopefully we'll have enough, because it's a much bigger enclosure for the mill now, and yeah, should be an improvement. I'll show you something else here as well. Whilst we're here, this is a little mains. There's my mains IEC connector. That comes in and goes through this filter, then into the pump. And I added this because every time, I could almost guarantee, every time I turned the pump on in Mark III, it crashed the computer. So I tracked it down to horrific spikes coming off this motor. So that has cured the problem quite handsomely. And like I said, this was scrap off another piece of kit, an old printer or something. Definitely worth doing. If you get any EMI problems, start filtering stuff. This is the acid test for this tank. Will it still fit? Ah, yeah. Perfect. This is the next challenge, to work out how to mount this about there and make it so that I can slide it out. While you weren't looking, I've added an adaptable box, which is just for connections. This and another hole. This is the washdown pump, which is going to sit quite nicely on the bottom there, and the cable is going to go through there into my little adaptable box, and then out on, if I can get it out, come on, an aviation plug, live, neutral and earth. If my calculations are right, and they often aren't, this should fit neatly in there. And it's held in, you can't see this, but I'll show you a shot. It's held in place by the leg in the corner there. And then this slides in like so. That's bloody excellent. I'm going to have a, I don't know if I'm going to have a removable panel or just a hole. But I tended to do this so that you can use a watering can to fill the tray up. Excellent. To mount the power drawbar master cylinder, I I need to drill a couple of holes in here, which I'm going to then tap M10 so that I can bolt it on a shelf on the back of the mill cabinet. The bad news is I can't get this on the drill table, so I'm going to have to do it here in the vise. This vise looks like it's quite useful because you can rotate it round, so I don't have to be in an awkward position to get this all drilled. Right, excellent. Right, because there's going to be a fair bit of weight on here, cantilevered over the edge of this this plinth, I've made 5 holes in it, and I'm going to use these 100mm 4-inch screws, which will go into this batten. That should give it sufficient mechanical support, as well as having a fair bit of glue on the surface. Blimey, that's rigid. Losing control of my glue. Oh my word. Well, here we are a couple of days later, and unfortunately my camera crapped out, so I didn't get to record welding this on. But as you can probably see, my welding is improving. It's not good, but it is improving. This is the arm for the control panel, and I've got some temporary screws in there. Again, that welding is almost just appalling. I'm improving. So that control panel there screws onto here, and it's about the right sort of height, so the screen will be about there. That's my eye level, so that should be in pretty much the right position. I need to do some grinding here, and also I'm going to open up the top here. I started to do it with my little porter band, but unfortunately because this panel's in the way, it doesn't go any deeper than that, so I'm going to open the rest of that up with the angle grinder. That's so that the cables can go in there. Then I think I'll 3D print some sort of shroud to go over it to cover it up. And the main body of the cabinet is all done. It's fully filled. This has had a couple of days to harden, so it's ready for sanding. So it's really just a case of take the arm off, clean that up separately, sand the control cabinet, or sorry, sand the cabinet, not the control cabinet, and mask it up, take it outside and start spraying it. So yeah, I'm quite pleased with that. That's all come along quite nicely. Right, so here we are, fully sanded, masked up, and ready to spray. So let me get on. After 5 coats of paint, 3 coats of varnish and 2 of this hammer finish paint. And I have to say, the finish is absolutely cracking. It really looks like painted metal. I'm really impressed. I'll show you a close-up so you can see what I mean. There you go. The pattern has come out really quite even. I'm really impressed with it. You can still see the wood grain in places. There you go, I didn't fill the grain completely, so you can still see some marks of the grain there. So you might ask, how did I manage that? Well, it was with this spray gun. It's branded Clark, but I'm sure it's Chinesium, and it's called Professional Gravity Fed HPLP Precision Spray Gun, and the model is an AP14GF. I'm not sponsored, I just think it's a cracking gun. For DIYers and hobbyists, I think this is not bad. Would I spray a car in it? Probably, to be perfectly honest. In fact, we may have a go at that at some point in the future. Oh yeah, that's looking really quite swish. In fact, I'll go as far as to say that's looking really swish. I like that. unplug that. I am going to break the cardinal sin when it comes to lifting stuff, and that's don't ever get underneath it. Just want to wipe these ways. Apologies for not filming dropping it down exactly, but because I needed help from my wife and she didn't want to be on camera. I understand that. So it's now on its base and the 4 bolts holding it are in, but I've just got to tighten them down. Well, if you're still here after that 55 minutes worth of rambling video, then congratulations. Well done. You need a sticker. Right, let me just catch you up with the mill where we are. I had hoped in this video to have got this completed and actually be cutting chips with it. However, it's taken me, I think, between a week and 10 days to actually just get the control panel to work. So I'll just go through a few things here that I thought have been bloody hilarious and painful to say the least. The first thing, turned the PC on, hadn't been run for at least a year. The battery had gone flat, so that was an easy fix. New battery in it, a new little backup battery, a 2032, piece of cake. Then it refused to boot up, so I had to put it into a diagnostic mode, and it repaired the disk and booted up. So that was nearly a day to get it that far. Having done that, Mark III, the control software, didn't work. So it couldn't find any of the profiles, couldn't find any of it. So I had to roll back the machine, the PC, to a date that it did work, which turned out to be about 3 years ago, would you believe? The last time I'd actually done a backup. So rolled it back for 3 years, and that started to work. At that point, some of the controls started to come back to life, so I could actually select various things. Nothing would move in the machine, but I could select stuff. I did some diagnostic work, and I found that I thought I'll pick something that's relatively simple and fix that, and then I can work out the rest of it. So this is the lead for the touch probe. So it's just a single pin basically, and in the diagnostic page in Mac 3 it was working. It said it could see the signal of this pin into the control software, but it wasn't triggering the digitizing probe. So I thought, what's going on here? And I found out that the machine was looking for the digitizing probe on a completely different pin, on a 25 bin D-way in there. And then it became apparent I'd wired the D-type inside. I'll show you a picture of it in a sec. Showed you the D-type inside completely backwards. So I had to redo that. So here's the inside, and this is a standard 25 bin D-type that goes from here to the back of the PC, and I'd wired it in completely backwards. So yeah, what can I say? I've been doing this stuff for years. I should bloody know better. And then things started to come to life. So nearly all of the controls worked, but the MPG now packed in. So that turned out to be, it had lost the config for the MPG. So I managed to reinstate that, and there was a spurious brain. Those of you who know Mark III will know what I mean by a brain. There was a spurious brain in the system that was active and shouldn't have been. So I turned that off. The MPG starts to work, and then I thought, yeah, I'm really getting there now. So I thought I'll try and run a bit of software, a bit of code, see if I can get the machine to actually work and respond. And it did, but the spindle didn't work. The spindle had worked, but now it didn't work. So I don't, to this day, know what the problem was with the spindle. I reseated a few connectors in the breakout board in the back of the machine, and it burst back into life. That to me is a little bit inconclusive, and I don't like that, because it could easily just stop mid program, and if it did that, the machine would still think it's running, so it will just plow a stationary tool into the work. It'll break the tool and damage the work. So I'm a little bit apprehensive about the spindle. And finally, the power drawbar packed in. So I started to install the power drawbar on the top, and it turns out that I was putting oil in the top of the system to top it up, and it was running straight out the bottom. So a couple of seals had gone. So I'm in the process of fixing that as we speak. So this machine has fought me for a week to 10 days just to get it to the point where it actually just basically works. So that's why we haven't finished this, finished it in this video. So apologies for that. I had hoped to be further along the road, but further along the journey. Anyway, thanks for watching. Do hit the like and subscribe button, and yeah, apologies for such a long video again, but we'll see you on the next one. Take care. Ciao.